Welcome back, students. In this class we are going to observe how to design the stick diagram using Nmos logic. Is it clear? Now you can observe this question. Draw the stick diagram of, first I have considered Nmos inverter, second I have considered 2 input NAND gate using Nmos. Is it clear? Now you can observe how to design these two questions in the form of stick diagram. Is it clear? Now first of all, we should be very clear how to design Nmos inverter and a 2 input NAND gate using Nmos. You know very well that the Nmos inverter consists of two transistors. One is what? Depletion mode transistor. Another one is an enhancement mode transistor, right? This is a depletion mode transistor and this is an enhancement mode transistor. Is it clear? This is V in and it is your output. Then it may be VDD and it is what? VSS. Okay, now based on this you have to design the stick diagram. And will you please tell me how the 2 input NAND gate? Okay, absolutely. That means once again here the pull up won't be changed. What is the pull up? Depletion mode transistor. Okay, since it is an AND operation, the two Nmos should be in series. This is VSS, this is A, this is B. If you assume that, then the output is taken. Is it clear? This is VDD. Is it understood? This is 2 input NAND gate and this is an inverter. Let's see how the stick diagram is going to be designed. Is it okay? Now you can observe very carefully. Yeah, let's start the stick diagram. If you observe that here very carefully, you are having two metal rails. Just draw the metal rails by leaving sufficient space. Okay, sorry for that. Okay, I am going to use the metal rails. This is what? VDD and this is for VSS. Okay, now you can observe these are the metal rails and you can write this as VDD and this as VSS. Okay, after that observe very carefully how the diffusion looks like here. Is there any deviation? No, it is very straight. Therefore I am going to consider the diffusion very straightly and later I have to give a contact. Now you can observe very carefully here. You required one depletion mode transistor, one enhancement mode transistor. Therefore I am taking one depletion mode transistor here. Observe very carefully. In this fashion I am considering the depletion mode transistor. You can observe there is a contact here. Yeah. Okay, now you may observe very carefully. Since it is a depletion mode transistor, what should be present? Yeah, I will use different color. Okay, implant should be present. Therefore I am considering the implant here. This is your implant. And you required one enhancement mode transistor. I am considering one enhancement mode transistor here. Now you can observe that I am using the same color. I will use the black color, one enhancement mode transistor. Don't forget, this is a polysilicon. This is a polysilicon. Now let us consider this is A. Okay, and you required an output here. Therefore you have to use once again metal. Therefore I am using, okay, I am using some other color to represent the output. I am using metal here. This is metal and there is a contact and this is Y. That's it, guys. This is the stick diagram of Nmos NAND gate. Don't forget here, this contact, especially this contact, is very crucial contact, this one. Why? Because it is the contact of polysilicon diffusion. Okay, therefore this contact is known as buried contact. This is buried contact. I hope that are clear. Now shall we see 2 input NAND gate stick diagram? Yeah, absolutely, we will see. Is it okay? Now you can observe the 2 input NAND gate. Now this is a 2 input NAND gate using Nmos logic. Now you can observe that how to design the stick diagram. First you have to take metal, by leaving sufficient space, you can tell it is a VDD, and it is VSS. Then once again, if you observe this diffusion, it is very straight, therefore you have to draw a straight diffusion, and there may be a definitely contact. Why? Because two different layers interact with each other, a contact will form. And you require depletion mode transistor, as it is same in this manner itself. I am considering a depletion mode transistor. Don't forget, this is what? Polysilicon. And you require an implant here. This is an implant. And how many transistors here required? 2 transistors. This is one transistor, let us consider it is A, and this is another transistor, let us consider it is B, and you require an output here, you require a metal, therefore I have taken the contact, and you may call it as Y. That's it, guys. This is 2 input NAND gate stick diagram using Nmos. Now shall we see some other? Okay, you may observe very clearly. Shall we see some other? Now you are going to observe the 2 input NOR gate. It is a 2 input NOR gate. Okay, 2 input NOR gate. Now I am going to design the stick diagram. First, what should we have to do, guys? Absolutely. First we have to draw the 2 metal rails by leaving sufficient space. Let us consider this is one metal rail. Let it be VDD. Leave the sufficient space. Now it is another metal rail. This is what? Absolutely VSS. Now you can observe this what we'll call diffusion. It is up to here straight. After that it is like this, and after that it is straight. Therefore you have to consider the same thing here also. Okay, now I am considering the same thing. Now you can observe. First I am going to consider the straight. Right? Okay, after that I have to consider this box, and after that straight. Is it clear? Then you have to give a contact here. Since it is a box, then here it should be like this. I hope that are clear. I have to take some thin one. Okay. Now since it is a depletion mode, I have to draw the depletion mode configuration. Now it is a polysilicon, and we require a implant here. Okay, I will draw with some other color, therefore it is very clear to you. I will use a different color to represent implant. Okay, it is an implant. Okay, after that you required what? Absolutely. After that you require 2 transistors here, therefore I am crossing polysilicon here. Why? Because we know when poly crosses diffusion or diffusion crosses poly, then it is what? A transistor. Then here you require a contact. Then I am using a metal here. Then it is what? Y. I hope that are clear. This is the stick diagram of 2 input. Sorry for that. This is a stick diagram of 2 input NOR gate. Shall we see some other Boolean expression? Yeah, okay, absolutely. We will see some other Boolean expression. Let us consider y is equals to AB plus C. Don't forget there is no whole complement. Therefore, you require what? Inverter. Let's assume that first of all you require depletion mode transistor as it is. Why? Because it is an Nmos transistor. Only the logic is applied to pull down. See here AB is there. Therefore, first these two should be in series. This is A and this is B. Okay, and this should be in parallel. This is what C, and here you require a VSS and the output is collected here. The same manner I'm going to draw the stick diagram. First I'm going to draw a metal. Sorry for the interrupt. This is metal. It is VDD. I'm leaving a sufficient space. It is what? VSS. But don't forget here, AB plus C is given. There is no complement. Therefore definitely here you required an inverter, guys. Okay, therefore you required an inverter. Don't forget that. It is a very important thing you have to tell. You required an inverter. This output should be given as input to this. This output should be given as input to this. Is it clear? Then only this Boolean expression is satisfied. Otherwise it is not AB plus C. It becomes what? AB plus C complement. Okay, now you can observe that here you can observe the diffusion, how the diffusion is straight, after that a box, after that straight. Is it clear? Therefore we have to draw in this fashion itself. I am going to design in this fashion, straight, after that there is a box, after that straight. Sorry that we'll draw some more neatly. After that there is a box, after that straight, after that there is a box, after that straight. Is it clear? There is a contact. When two different light interact with each other, contact will be formed. Then here, since it is a box, we have to represent like a box. Okay, now you can observe that depletion mode as it is. Then you have to draw a depletion mode transistor as it is, and it is a what? Polysilicon, absolutely. And there is a contact here. It should not cross, that is very important. There is a contact and there is an implant here. Sorry for that. It is an implant and you required an output here. It is a metal. Let us consider it is not a Y, and you should draw two transistors here. Very importantly, this is one and this is another one. I don't have sufficient space. I think that you understood very well, right? This is one and this is one. This is polysilicon. This is let us consider AB, and this is one more transistor C, and you have to draw an inverter here. Therefore you should take a metal like this, and you should take a metal like this. It becomes VSS, it becomes VDD, and you should take a diffusion in this fashion. Are you clear? And you should consider a depletion mode transistor. Okay, I will use some spacey one. Okay, this will be the depletion mode transistor, and the gate source should be tied together, and there must be an implant here. There must be an implant here. Okay, and you required, yeah, absolutely, an enhancement mode transistor here. Okay, and this output should be tied together here. There is a metal and it will contact. I hope that clear, and you have to take an output here. Is it understood? Okay, now in this fashion you have to discuss about what we'll call the stick diagram of Nmos inverter. Is it clear? Now similarly for Pmos inverter, if you observe that for Pmos inverter, in this Pmos inverter, don't forget the logic is given to whom? Pull up. Absolutely. Here the logic is given. The depletion mode is considered as pull down. The gate source should be tied together. Is it understood? Okay, that is an important point you have to remember. Okay, the input is applied to the logic, and the pull down is the input is applied to pull up, the pull down is fixed. Okay, I will draw the NOT gate for that. If you observe that stick diagram, I'm going to draw the NOT gate for PMOS transistor. This is a metal and this is a metal. This will be VDD, this will be VSS. Now there is a straight one and straight one diffusion I am considering. This is a contact. Now you can observe that here, okay, you can observe this one like this. We are having a contact here. Okay, I should just draw the contact, don't forget that, up to here itself. Then it becomes gate source and you have to draw the implant here. This becomes implant, and don't forget it is what? Polysilicon. And here you have to cross another polysilicon and you can call it as A, and you have to take an output between pull up and pull down, and you may call it as Y. I hope that are you clear? Yeah, that's it guys. In this passion you have to design a PMOS NOT gate. Is it okay? Thank you very much. In this class we have seen how to design the stick diagram using NMOS and PMOS. Okay, in the next class we will discuss about how to design the stick diagram using CMOS. Thank you very much. Have a nice day.